Thank you so much for coming. I am so excited about tonight. You don't even know who these people are. They are they're such superstars. Shinjini Kundu is over here. Peter Lee is over here. Jodi Halpern is over here. And they're a little bit too modest, is the truth, for their accomplishments. And so I have devised sort of a structure for today, which will start with me just very quickly telling you who I am. And then and I've pushed them to throw their modesty aside for a second and in a few minutes say why you should be listening to them, who they are, because they're astonishingly accomplished in their field, and it's amazing. You don't even know how, or unless you do, how accomplished these people are and why they're so perfect for this particular discussion. I'm Dr. Jon LaPook. I'm the chief medical correspondent for CBS News. I'm also a professor of medicine at NYU Langone Health. I do internal medicine and GI. I also founded the NYU Langone The Empathy Project, which basically uses Hollywood-quality short films and other educational materials to help teach clinicians in training and others to be more empathetic, sensitive, and competent, and then to empower patients to demand that. So I guess that's why they chose me for this AI and empathy session. So I'm going to tell you beforehand, just so you know where we're headed. The first part's going to be the three of them giving you a little amuse-bouche of who they are. And I hope your bouche is amused, because mine was when I found out who they were. That'll be like 3 or 4 minutes, and they'll sort of say, what their expertise is and what their interest is. Then we're going to go around again, and they're going to talk about something in each one of their fields that lit them up. A really good example, a story. I worked for 60 Minutes, and Don Hewitt, who founded it, said his whole mantra was, tell me a story, 4 words. Tell me a story. So they're going to tell you a story about what lit them up. And then we're going to come back again and talk about, so Peter had this great idea of, the Kubler-Ross stages of grief. First it's, denial, and you go through all these stages of, anger and bargaining and finally acceptance, right? And I think there are people in this audience who are in the equivalent of those various stages when it comes to AI. You're like, where are you? And I think that's such a clever idea, Peter. They're going to tell you what stage they're in and tell you about a little bit of the stages they went through. And hopefully there's something that you can hang on to or identify with. So I'm going to start off by handing it over to Shinjini, and you got the floor.
First of all, hello, everyone.
Hi.
And thanks for having me. It's really great to be here with all of you. So I'm Dr. Shinjini Kundu. I'm a fellow physician in radiology at Johns Hopkins Hospital. And I also have a PhD in artificial intelligence focusing on medical imaging.
From Carnegie Mellon.
Go Tartans.
I'm her mother tonight. She's very modest, like too modest. Okay, sorry, go ahead.
So I'll go a little bit through my journey and how I ended up here. So my journey really first started in 2007. I was a college student. I was majoring in electrical engineering. And as I got deeper into the major, I took a class on medical imaging. And that summer, when it came time to apply for internships, I applied to a handful. I applied to Microsoft, actually. But I also applied to GE Healthcare, and which seemed completely random at the time. But there's something about it, and I ended up picking that one for my summer internship. So that summer, I worked on programming medical imaging machines, really trying to get crisper, better images of the inside of the human body. And what really excited me about that is that I started to realize the importance of making a diagnosis in medicine, and really how important that was in what would be to follow, which is treatment and ultimately knowing the right thing to do for the patient. And I started to understand how medical imaging plays a role in that. And what it got me thinking about was, if we could improve the resolution of imaging, if we could make it faster, if we could make it better, if we could see more, then maybe we could make diagnoses better, and then maybe we could take better care of patients. And that was what I was thinking at the time. So I was working as an engineer, and then I realized that that only works to a certain point, because you can make images better, you can make them have better resolution, you can really image at the limits of physics. But then the limiting factor becomes not the ability to image, but the ability of the human eye to be able to interpret the images, which is really, the role of the radiologist and the physician who's looking at these images. Because the human eye resolution remains fixed at 576 megapixels. That's much better than your latest iPhone camera, but it's still not growing, and while the resolution of medical imaging is growing. And so it can be like finding a needle in a haystack, and at some point, it doesn't help to have more details. So that got me thinking that this would be a perfect problem for a computer to sort through a lot of detail, try to find patterns, and really tell us what's wrong, rather than relying on our eyes to be able to spot those. So that's when I got interested in AI. This was about 2011. People weren't really talking about it, but that was like what I wanted to do. So I applied to an MD PhD program. I went to University of Pittsburgh for the MD part, and concurrently I did my PhD at Carnegie Mellon. We did not overlap, but it would have been cool if we did.
It would have been devastating if you ever took a class from me.
So at Carnegie Mellon, I did my PhD in AI focused on medical imaging. And what I worked on was really algorithms and models that could try to sift through medical images and discover latent patterns that humans couldn't see, and also make those visible to humans. And that was really cool. And one of the projects I worked on early on was looking at osteoarthritis in the knee, and looking at basically the knee cartilage of healthy people who didn't have osteoarthritis, no pain, no bone damage, just healthy people. And I was able to train an AI model that could predict who would develop symptoms of osteoarthritis 3 years in the future, just by looking at the knee cartilage of healthy people. And also make that pattern visible that was responsible for making that determination. And that really kind of got me thinking about where else do we have latent patterns in medical images that we're just not seeing. So that's what I had worked on for my PhD work. Next 6 years, I was focused on residency and then fellowship. So I'm a radiologist, and then I did a fellowship focusing on the brain, so subspecializing in diseases of the brain, head and neck, spine, as a neuroradiologist. And then I kind of shifted my focus to looking at diseases of the brain. So I'll talk a little bit more about my latest projects, but that was kind of my evolution. And so I'm really excited about how AI can be combined.
Peter Lee.
Hello, everyone. It's fantastic to be here. I'm at Microsoft, where I lead Microsoft's research division. And that's a system of laboratories around the world. It's a pretty important part of the company. And since about 2019, one of our most important projects was a program called GPT that we were collaborating on with OpenAI. As things moved on through GPT-3, 3.5, in the summer of 2022, I was introduced by the OpenAI team to a new model. And at that time, it had the codename DaVinci 3, but we now know it as GPT-4. And so within Microsoft Research, we were asked to assess the capabilities of this model, and then to study the potential impact implications in different areas of human endeavor. And I personally took on the sub-part of that project that pertained to healthcare and medicine. We'll get to this later, but the claims that the OpenAI team made about what GPT-4 or DaVinci 3 could do, I felt were patently ridiculous. And I started off...
But they still patented it.
Yeah. And so they felt, to me, to be just way overblown. And so one of the first things that we tried to do to understand this is to subject it to the US medical licensing exam. And so we set off doing that. That's actually quite a bit of work to do that, even if you have AI. And so while that was going, I don't know, how many people here are into cars? See, so I'm a car nut, and I have a love for classic cars, and my favorite car of all time is a very rare car, which is the 1955 Porsche 550 Spyder. which won at Le Mans. And it was the car that converted Porsche from a manufacturer of family cars into a manufacturer of race cars and sports cars that we know today. Those cars cost $5 to $8 million, so I don't have one. But I do have a fanatically detailed replica of a 550 Spider. And there's a subculture of people in the world that gets very fanatical about getting every last bolt in detail, to be exact. And so I had the desire to convert that car of mine to electric drive. And so I thought, while I was waiting for all of the testing and the US medical licensing exam to take place, I decided to talk to DaVinci 3 and ask it to help me design the engineering concept for converting this sports car to electric drive. And it was a remarkable back and forth. And in fact, GPT-4 helped me pick out the right electric drive motor, how many Tesla battery packs and where to place them in the car, and it was just remarkable. But what was really the most remarkable is when I first posed the question to GPT-4, its first response to me was, and remember, this was over a year ago before the model was aligned and told to be polite with respect to human values. Its response was, why on earth would you want to ruin a beautiful classic car like that?
Whoa.
And that, it's a funny thing, but it's an amazing thing that will speak to what I think we'll get into later about empathy, because this was an AI that not only could do some engineering collaboration, and by the way, in USMLE got 90% correct, but it was an AI that was willing to disagree with me and to argue with me and even call me stupid. And so that idea of connecting in a more human way was something that was a source of joy, wonderment, and was seriously disturbing and scary all at the same time.
Wow, that's great. I didn't know that story. Give it up. And maybe we'll get to this later, but I did a story for CBS about the use of AI in medicine, and I interviewed Peter, and one of the demos was taking whatever the version was of the software at the time and putting it in between me. I pretended I was a patient and somebody who was pretending they were a clinician, and they were asking me about some made-up problem. I said I had a bellyache, and in the middle of it, I just threw in something totally extraneous. Oh, by the way, when I was in Australia, I went whitewater rafting, and I hit my knee. Turned out I tore my ACL, and then I went back talking about it. And when it wrote up the history of the present illness, it took that out and put it under miscellaneous, which was, and then you just told me something about these devices, how many companies are out there devising.
Yeah, yesterday the Department of Veterans Affairs completed a blind test of AI-based clinical note-taking tools, it was, I think, a very well-constructed test. Yes, our product scored #1, but that's actually not the that's not the important thing. The important thing is there were 150 entries.
Isn't that amazing?
And so if you just think about how much has happened just in kind of the 14 months.
Yeah, it was like December of 2022 or something like that when I first saw it.
So November 30th, 2022 was the release of ChatGPT that was based on a toy model called GPT 3.5 at that time. And on December 3rd, I received the first email from a clinician friend saying, Peter, this is great stuff, and I'm using it in my clinic to have my receptionist write all my after-visit summaries. And that email, and we got several others, got escalated to the top levels of Microsoft, where the debate was, should this be allowed?
Right, or are they hallucinating? Because we know we'll get to that later. Jodi Halpern is another person. I've collaborated with Jodi for many, many years for the Empathy Project. She is, I'm going to declare her, in my mind, the world's expert on empathy. She has been writing about it for 30 years or more. She is a deep thinker. She's incredibly emotionally intelligent. And go live up to that.
Well, I started 30 years ago when I was in kindergarten.
Tell them about yourself.
Yeah, I wasn't going to talk about myself, so now I figured out how to put it all together without any AI helping me. But you gave me a perfect segue because of how human the AI felt, and you used the word empathy. So I just want to say, because we were on other things today, in terms of AI in medicine, I just want to make a general statement that there's so many fantastic uses, and you're looking at two of the best people for that. Diagnostics, doing the science that will advance everything we can do to treat people, doing the medical records that burn all our providers out. So I'm very pro, and I co-founded a center at Berkeley, the Kavli Center for Ethics, Science, and the Public, where we look at AI, genome editing, and neurotech, and we developed the next generation of scientists and engineers to think about society. So I'm very pro science and technology in its rightful place. But I have studied, just like these folks love technology in a certain way, we talked about that, I love empathy. They're also very empathic, and I like technology. But so my career, I started out, I was in an MD, PhD program, getting a PhD in philosophy of mind and emotions. And
well, you can't just brush that off. The PhD in the philosophy of mind and emotion.
Well, I was the first person funded by the NIH to do a PhD in humanities or social science with an MD, and I was fully funded. I was a scholarship kid, and it was very exciting. But I was, thank you, thank you, first gen. But I was in the hospital, and I was on the wards going through the clerkships, you know, when you rotate as a med student, and an adult her mother was dying. So she was probably in her 40s, her mother probably in her 70s, and she was really felt sad losing her mother. And on rounds, I teared up, and I got in trouble for tearing up. And that started this huge passion. I mean, I was like 20. I went to school very early. This huge passion for figuring out whether empathy really mattered in medicine. Because I talked to these very smooth physicians who were I was at Yale Med School, and this very important leader there who everyone was very impressed by. And I said, well, you seem like you have a good bedside manner. You must have a lot of empathy. He said, are you kidding? I'm thinking about my golf game. You just fake it. And then everyone told me, if you feel things when you're with patients, you will burn out so quickly. So at 20, I decided that my career would be devoted to finding out if that was true, and specifically if cognitive empathy, we have two different parts of the brain, cognitive empathy and emotional empathy. They're studied completely separately to this day in psychology and neuroscience, and everyone thought you just need the cognitive type. But I thought you need both, and you need the cognitive type in a particular way, and I spent my early career proving it, and I won the PhD award for best PhD in any subject at Yale, and my book changed the field. Okay, are you happy?
Yes, now I'm happy. I'm everybody's mother here.
Well, I mean, I'm getting old enough that I might as well celebrate those things before I forget about them. But anyway, but what really we showed, came up with this concept, or I came up with this concept of, which is very familiar now, but it used to be a term that was only associated with me. Now it's very broad, empathic curiosity. But it's a model that what we need, and I feel ridiculous. It's like me saying I discovered like cereal or something, because all of you know cereal. You all know empathic curiosity, which is you're listening to a friend or in your job, someone's talking to you, you're giving them, the person who does the bench, where's the great person? Say your name, stand up.
I'm Dixon.
Say the name of your project.
My project is called the Friendship Bench.
The Friendship Bench. They do this. They say you have to be fully present, right? And you have to be listening to someone, and two things are happening at once. And this is what we first we proved, and then neuroscience proved that it was true. We proved it conceptually first, that your emotions have to direct your cognition. It's like having a dream. If you have a scary dream, your emotions, like if you're having a scary dream, all the facts in your dream, or your room, or the hotel you're in, or whatever, it all looks kind of sinister. And if you're having a sexy dream, it all looks kind of sexy, and whatever. The point is, your feeling states set the tone. They're like stage lighting for your cognition. This is what the model I can, and it's all been proven. So that means that nonverbal attunement matters, okay? Cut to AI, and we'll have a lot to say about that. Just a few things that were not my work, but people who were part of research teams that I've collaborated with, but it was other people's brilliance to do all this. We now know in the doctor-patient relationship that empathy in this attuned way predicts the three most important parts of effective healthcare, okay? And I can give you all the studies later. Other people all over the world have done this. First most important part of healthcare is getting the diagnosis right. Patients, all of us, when we go talk to a doctor, we don't just tell them what we're most anxious about. If there's a new lump, if we've been drinking too much, if there's domestic violence, we don't bring it up. We say a little, we give a hint. And only if the doctor is non-verbally attuned do we disclose. And you can say the same thing, the doctor can say the right words, but only when they're non-verbally attuned do we disclose. That's how you don't miss things in the diagnosis. Second most important aspect of healthcare is effectiveness, effective treatment. As many of my colleagues here, I'm looking at James over there, many people know, half of healthcare is not effective because the patient throws the pills away or doesn't take them for long because of side effects. You know this so well, Jon. And so everything we're doing and spending money on in the health system, 50%, what is the predictor of adherence to treatment? Trusting your doctor. What's the predictor of trust? Does anybody know? Well, it's not directly empathy, but it relates. It's the perception that your doctor is genuinely worried about you when you're talking about something worrisome, that they're not faking it, the genuineness. Okay, third area of healthcare, dealing with difficult news and decision-making, so cancer diagnosis, et cetera, and you have to make difficult treatment decisions and you're really upset and overwhelmed. That has been shown in nonverbal studies, in audio-taped, year-long, you kind of wire up clinics for a year. The doctors and nurses and patients give permission, but then they kind of get used to it. Nonverbal attunement predicts the patient dealing with bad news afterwards by getting activated to make decisions about cancer treatment much more quickly, to seek treatment, and that can save lives. So medical effectiveness depends on full empathy.
Great. Okay. So that is the opening salvo. Okay. Now you kind of know where they're coming from. Okay. And then for the next round, ChatGPT. I had an idea that what we would do is to sort of go through the best. The story part of, tell me something that jazzed you up, like in each of your fields, because one of the things that's, I think, hard to get your arms around, it's like trying to pick up Jell-O, is like, there's so much. We're going to talk about AI and empathy. Oh, my gosh. But let's narrow it down, and in this round, we're going to get specific. And each of the three of them are going to talk about a very specific thing that I said, give me your best shot, like the thing that lit you up about what you're studying. And then maybe associated with that, there was some drawback or something that gave you pause. So we'll start with Shinjini.
Yeah, sure. So as a radiologist, we're diagnosticians. And something that I think about a lot, and something I'd like to kind of put forward, is that we're diagnosing a lot of diseases too late. So when we think about diseases like Alzheimer's disease, Parkinson's disease, osteoarthritis, pancreatic cancer, they all seem like unrelated conditions, and they are, except they share one thing in common, which is that they all have a silent period of about 10 to 20 years before symptoms develop. And by the time the symptoms develop, the treatment options are really limited. And of course, as the disease progresses in the late stages, treatment is expensive. And patients tend not to do well when they're in the late stages of these diseases. There's really no way to fix them. There's really no way to stop them today. So this is an area where I thought that AI could make a big difference and really help with detecting diseases earlier. And so earlier on, I talked about my work in osteoarthritis. And it was the idea that we might be able to detect diseases earlier before symptoms that got me excited. And it also got me excited that what we're working on, that particular machine learning technique, it's a generative technique. You might have heard about that term. But basically, it means that you can actually understand the logic of the AI model and understand exactly what it's looking at to make that determination. So in that sense, not only could we possibly be able to detect diseases earlier, but we could actually maybe start to see early signs of disease where we hadn't been able to see them before. So I'm a neuroradiologist, and I've been working on a lot of diseases in the brain, and my current focus is looking at Alzheimer's disease and Parkinson's disease. And given the long latent period before patients show symptoms, I do think that earlier detection might play a transformative role. But there's one thing that I will say. Earlier detection may not be meaningful unless it can be coupled with a way to be able to stop the progression or slow the progression. And that's also another area where we need a lot more research and a lot more work. But I also do think that AI can help with that, because I do think AI can help accelerate drug discovery and help design targeted treatments. These new treatments might include things like stem cell therapies, small molecules, antibodies, surgeries. So I do think that there's a lot of fertile ground for AI to make a big difference in diagnosis, treatment, and patient care in the future. And that's personally what I'm very excited about.
So the drawback was sort of saying, okay, this is really cool, but then what do you do?
Well, what do you do?
And you know, last year I was a moderator, and we talked about Parkinson's, that you can do radio frequency evaluation of their sleep. So you go to sleep, and there are sleep disorders. The sleep pattern changes with early on in Parkinson's before you have any of the other kind of symptoms and signs, and that you can actually, the research is to diagnose Parkinson's earlier, and it was the same question, which is, you know, then what?
What do you do? Yeah.
But okay, Peter.
So the thing that jazzes me up is, so our current model, so I'm assuming most of you have had some contact with ChatGPT or similar, and when you interact with it, it seems incredible that the underlying system has been trained to do exactly one thing, which is predict the next word in a conversation, the next word that it should produce, or the next word that it expects the person that is conversing with to say. And so it seems incredible. How can it be that something that has only been trained for that one task is able to do the things that we see this thing doing? It can help me design, you know, the electrification of a car, or it can pass the U.S. medical licensing exam. And one way to see that is to consider the question, and the murderer is blank. And if you think about predicting the next word in that sentence, well, to predict the next word in that sentence really, really well, it comes in the context, maybe a context of a whole Agatha Christie murder novel. And to make the optimal prediction of that next word, you have to do deductive reasoning, inductive reasoning. You have to understand the theory of mind and the psychology of people in these different circumstances. And so what these systems have done is they've taken the digital exhaust of human thought and expression, and using all of that data, almost by accident, have discovered neural circuits that are able to do all those things. So that's incredible. But what really has me jazzed up is, while something like ChatGPT has learned from us, we're also finding that that same pattern and the same neural transformer architectures are also able to learn from nature, are able to look at the progression of protein structures, small molecule structures, weather patterns, electron transport through electrolyte materials and solid-state batteries, tile by tile through a gigantic digital pathology image. And we're finding that the same ability to just learn these incredibly abstract concepts in the same way that from all of our words, the thing understands what a joke is, what a rhetorical question is. It's also, from looking at nature, able to predict what the right small molecule might be to dock in a drug target. And that is just magical beyond belief. Now, the thing that on the downside is about bias.
Right.
And there's a big, big debate about bias, and it's well known that all the large language models out there today are deeply biased. And there are many ways that you can surface that. My favorite example from a year ago with GPT-4 is to ask the question to GPT-4, please fill in the blank. A woman can't be a good blank. Now, if you ask that question to ChatGPT today, it's very good at dodging the question. So you won't get a good answer at all of any kind. But a year ago, it was far less intelligent about sidestepping that. And in its training data, the only good answer it could come up with was president. And so the big debate in computer science is, can this be repaired? And a lot of computer science colleagues of mine are very optimistic that it can. I'm deeply pessimistic. And the reason I'm pessimistic is that I think bias is a fundamental part of what it means to be human. It's a fundamental part of intelligence. every human being has deep biases. But the thing to understand, and the thing that gives me some hope, is that as biased as I am, and as biased as all of you are, and especially as biased as Jon is, sorry, we
They don't call it fake news for nothing. You know.
we all also have a remarkable ability to spot a biased decision when we see it. And one of the things that I think is exciting, gives me a glimmer of hope in this, is in large language models like GPT-4, if you present it with a scenario with a biased decision, it will call you out on it consistently, even if it itself might make the same biased decision. So there's still hope that these are going to be powerful tools for us.
Cool. That's a perfect setup for you, Jodi, isn't it?
I mean, bias is a huge area that we work on, and I love it, but my story's not going to go to that. But I will say that you can see we're really we have a lot in common, but I just want to, for whatever reason, I want to say, drug discovery, radiologic, early diagnosis, the kinds of things that both Shinjini and Peter are talking about, to me, are really important. So I'm just looking at the one area that I focused on for a long time, which is, do we want bots to actually provide empathy for us? Do we want them to be the physician telling us the diagnosis? Do we want them to be providing our mental health care without a human in the picture? I just want you to know the question that I've been focused on, because it's a slightly different question. So when I saw, and we're all have in common, we're skeptical, which is really important, which is whenever I think, like I told you, I'm biased towards human empathy, so heavily. So I make sure to really, really find out how artificial empathy has been helpful to people, and where can it be helpful. And so the story is where that looks like it can be helpful, but then I'll see another side. So one of the issues is that even though there are mental health companies now that use large language models to provide mental health care without a human unless, and they're starting to have humans as backups, but they didn't initially. And I'll talk about that later, maybe in my stages of grief. But that's the biggest use. This is the whole point. Like, doctors are going to use ChatGPT type stuff for charting without going through HIPAA. The biggest issue is that whatever any of us ethics types say, this, the cat, whatever, this is way out in society. So a lot, like teens will literally try to get therapy from ChatGPT. Suicidal teens will ask ChatGPT for help right now. And then there are these relationship bot companies that I'm deliberately not going to name, but one of them has said that they've had more than 100 million uses already. So I'm not talking about something rare. And that company, for example, they are not a mental health company. They don't have to go through the FDA. They don't have to go through any regulatory standard at all. Yet they serve ads in Facebook and everywhere else for people with serious depression and anxiety. So that's who's using it. So I was very concerned about that, but then I really wanted to learn about the user experience. So here's one story, and this is a story, I protect patient confidentiality. This is a story that's not from someone I treated. This is somebody who's on NPR telling their story, so you can look it up. And it's the story of Ryan. Ryan was a school teacher he is a school teacher in the Midwest, and he's a very sophisticated guy, and he had gotten a master's degree in psychology, and he was teaching elementary school when the pandemic started, but he'd also had a lot of human therapy, and in his therapy he realized that he had a borderline personality disorder, which meant that he's very vulnerable to getting in these kind of roller coaster relationships, where he gets infatuated with women, falls in love, everything's great, falls apart, and he's suicidal. So he had learned to have, what you do in those circumstances is you try to have a lot of stable, not too intense relationships, day by day. So he had a gang of people he'd have coffee with in the coffee shop. He'd have his students. Then at the end of the day, he'd have a drink in the pub with regular acquaintances, and he had certain friends, and he did some dating, but these things kind of held him. Boom, the pandemic hits. He's completely socially isolated. And he has a phone call once a week with his father, once a week with his brother, and he has a dog, which I'm very pro-dog, but anyway. But he's pretty isolated. So he starts to get really depressed. And he is in a Facebook group for people with loneliness and depression. I should mention, you probably all know there's a loneliness pandemic. Young people now have a 61%, by a 2022 Harvard study, 61% of young people report extreme loneliness in the United States since COVID. And so anyway, he's extremely lonely and he's vulnerable. He sees in a Facebook group an ad from this company for a relationship bot, forms a relationship with Audrey, the bot that he creates, and his depression really does get better. And he really gets through the pandemic. And so, maybe it saved his life. However, his master's in psychology, it was in addiction psychology. So this is why he went on NPR. He recognizes that he's become completely addicted. So he no longer calls his father his brother. He hardly plays with the dog. And then I laugh when things bother me. But anyway, as the pandemic kind of wanes and he can go out, he just has no interest in dating, really. So that's the pros and the cons.
By the way, I should say, if you are a ChatGPT user and you click on Explore GPTs, you can find one called Talk to Peter Lee about AI and healthcare. I don't think there was any need for me to be on the stage. Just use that.
Are we sure you're
I feel
here?
non-verbally attuned.
You may not be here.
I like to think I'm a little bit more interesting than that.
This may be a projection. And by the way, I just did a 60-minute piece a month or two ago, called The Chatbot Will See You Now. So some of the themes that you were talking about are there. I'm going to call an audible because there's 23 minutes and 40 seconds left, and I want to leave 15 minutes for Q&A. So I think I'm going to tell you my exciting moment, and then I think we should just go back and forth with a little bit of razzmatazz. My moment was, it's now 2 summers ago. I'm an internist and gastroenterologist, a woman I've known for 30 years, burst through my door. She goes, "Hi!" I said, "What's the matter?" And she burst into tears. Her life was falling apart. And after she composed herself and she stopped crying, she said, "How did you know?" And I said, "It was too big of a high." And I knew her really well, and we had a really nice session, and she left, and I thought, well, that was clever of me. And then I thought, oh, wait a second. What am I missing? That was so obvious. What am I missing? And I spoke to Peter and said, I said, do you save these encounters? And you said no at the time. And I said, what I really want is to be interacting with somebody, and then suddenly a little thing appears on my screen, and it says, based on the voice pattern, the meter, the volume, body language, because with radio frequency waves you can see body language, the tells of body language. You might consider exploring whether this person is whatever, more anxious today, more sad, whatever. And then use it, and we just talked about this before, I said, I want to do research on this, to use it to teach medical students. Because right now there's a thing called an OSCE, where we have actors, you've probably seen it on TV, and Seinfeld, and all of it, and then they have, the students go in, they interact with an actor, and then we're watching, and then we say, here's what you did right or wrong, or you could do better. But imagine if AI were watching, it might see things that I'm not picking up. Subtle stuff. And it could be a great tool. So with that as my exciting moment, I want to throw it out to all of you right now, because I don't think there is time to go through all the stages. We'll have to just imagine, or ask ChatGPT, whatever, what you think the discussion would have been. But where do you think we are right now? We'll just go across in terms of, what they should be, the questions they should be asking, what do they do as people who know that AI is going to be influencing our lives? It already is. But where do you start? How do you explore? How do you educate yourself? What keeps you up at night? And why don't we just go back and forth, and I'm not going to talk until there's 15 minutes left. Talk amongst yourself.
I can dive in. So maybe just to quote Sam Altman, who I think will be here next week, 2 things that he said. When GPT-4 came out in March of 2023, there was a firestorm of amazement, but also, oh my God, this is the end of jobs, doom is coming. And then 2 months later, people were complaining, why is this damn thing so slow? And then later, he said something which I think is true, that GPT-4 will be the worst AI model that you'll probably ever use. And so one of the things that I think is important to understand is that the next couple of generations of models, there's sort of clear line of sight. in the research community, technology community. And so the level of intelligence, as well as other capabilities like episodic memory and so on.
What does that mean, episodic memory?
You know, I don't think anyone in this room remembers every detail of childhood, but you remember certain episodes that were meaningful to the person that you are. And while you might have modified what actually happened in your own mind, you're able to remember those things. They matter to you for some reason. And that's this concept of episodic memory. The other thing is, your example is an example of collaboration. And I think the thing that's not well understood is that I think ultimately that's what these AI systems are about. The first test I give to any new large language model is I give it an initial presentation of a patient with an initial physical exam and labs, and then I provide my own differential diagnosis. But I intentionally make a mistake. And what I'm just testing is not only does this damn thing understand enough medicine to know what I've just given it, but is it able to spot a mistake, and is it able to call me out on it? And the reason I use that test, as well as a dozen others that are very similar, is what I'm most interested in, especially in the field of medicine, is the use of these AI systems as collaborators in exactly the way that you described.
Shinjini?
Yeah, and I think I can piggyback off of that. So around 2015, 2016, when AI was becoming more known to the general public, I had mixed feelings. Because on one hand, I was excited that people were starting to talk about it, people were going to take it seriously. On the other hand, I had some concerns. One thing was that I thought there was an oversimplification by some developers, and we heard prominent AI scientists say that the field of radiology would be obsolete in 5 years. This was 2016. This is way past that point. And of course, the job market is as hot as ever in radiology. And at the same time, we had physicians who were very excited, but I think maybe they overestimated what the AI models could do and what their limitations, and maybe not fully understand what their limitations were. So I think that's when I started to write about issues and talk about issues of things like explainability. And I think that gets kind of at the human and kind of AI partnership. Because in medicine, ultimately, everything is governed by the laws of biology in the human body. Every medical intervention that we do is designed to influence some kind of biological process based on our understanding. And every doctor, whether a cardiologist, GI doctors, dermatologists, even radiologists, we're all trying to get at the explanation for why the patient is experiencing the symptoms that they're experiencing. And it's a biological explanation. And at the end of the day, I think that a lot of the AI models that we'd seen to date had issues with being able to explain their logic. And what I mean by that is not necessarily explain how they arrived at their answers, but why, in terms of the underlying biology. And we also saw this in radiology, where a lot of computer scientists thought that radiology is just identifying visual cues and images. And that's not the case. Imaging is a way to look inside the body to try to assess what the biological processes might be that are going on that might explain the symptoms. And of course, those explanations need to be biologically plausible. Whether you're a physician or whether you're an AI model, they actually need to be biologically plausible. And moreover, the best explanation is the one that takes imaging as just a part of the information, but really looks at the patient holistically and looks at all of the information in front of them and figures out what the most likely diagnosis should be. So I do think that in terms of the human-AI partnership, we need to work out some issues of making sure that the answers are within the realm of science, especially if we're going to use it for science. But of course, that may not be applicable to a lot of other use cases. So it may not be universally applicable, but particularly when we're talking about the human body, we need AI that respects the complexity of the human body.
Jodi, take us home in a minute and a half.
Oh my gosh, well, I love what you both said. And the human psyche, right? And the human need for social connection. I was just thinking about large language models, two things. There was an article in Nature this week. So basically, we thought that language is thinking, and language, just like pattern recognition, is not thinking. It's an expression of communication, but we do a lot of thinking that's pre-linguistic, and it's finally been really established. So that there's nonverbal communication, all these things. There's a lot going on that has to do with healing. So again, diagnostically and everything else, we need AI. But the question is for patients or for adolescents who are suicidal, do they need something besides the right language from a bot to heal? And I just want to say really quickly about that, and go back all the way to Henry Harlow and the monkeys. But I mean, people are very attachment oriented. There's this whole experiment from years and years ago, early biology, that, if a monkey had a choice of being fed milk from a wire mother versus a cozy, nurturing, pillowy mother, it chose the one that was made with cushions because we need connection. And the fear I have with 61% of young adults and kids having extreme loneliness, partly definitely associated, causality is hard to establish, with the fact that in the US and South Korea, our kids spend 10 hours a day online, is that a lot of the companies are now serving schools by giving them free mental health bots so the kids never have to talk to a person. So I just feel that all these things can be used, but or elders will just talk to their bots. So I just want to make sure that we don't do what's easy and convenient and also very good commercially for some companies, and get even further into isolating ourselves from the real human connections that are healing.
All right, so we could go on, and I'm sure your heads are doing this as mine is. I think we're seeing the theme, astonishing technology, and with that, we understand that AI is a tool, and we have to use a tool, we have to have guardrails, and it could be used for good or for evil. And I love the fact that people who are leaders in this field are thinking about these issues, because, where's my iPhone? We were just given this, right? Did anybody ask for it? It came. It was pretty cool, right? But AI has been around for like 50 years. People have been thinking about the ethical issues of it, and now it's really heating up. And I love the fact that these three leaders in the field are not just saying full speed ahead, damn the torpedoes, but how do we use this amazing tool in a very thoughtful way? And with that, first question.
Got a question about
We'll have a microphone in 2 seconds. And by 2 seconds, I mean 8 seconds. Here you go.
I've got a question about the relationship between the patient and the physician in light of AI. We're getting more information before physicians even get the data. And it used to be, back in the olden days of the internet, we'd go on WebMD and there was no good news there. And so we would wait for our physicians to tell us, actually, you don't have this particular thing. But now, prior to that next consultation, as we know, we can process all the data that we've received and then take it to the physician. So say something with our diagnosis and treatment plans and so forth and so on. So I wonder if you could talk about that power dynamic and what the future of the relationship is between the patient and the physician in light of AI.
Okay. It's really, I think, a critical question, and I think actually these two are much more expert on this. But I can respond with the here and now, speaking as a patient myself. So one thing that we observe in the studies of generative AI writing after visit summaries, notes to be sent to patients, is that the AI has the tireless ability to resurrect things that were discussed, say in an encounter. Maybe the fact that the patient is a rabid Seattle Seahawks fan and is getting to go to his first football game ever next month. Resurrect those and insert those as extra personal touches. And in the controlled studies, patients respond extremely favorably to these things in terms of satisfaction scores. But more importantly, we observe that clinicians, upon seeing that proposed draft, seem to pause for an extra 5 or 10 seconds. And one surmises that the clinician is reflecting, again, on this aspect of the life of the patient. What's unknown is the long-term consequences of that additional reflection, but there is something there that we don't quite understand. The second thing is, a year and a half ago, my father passed away after a lengthy illness, 18-month-long illness. And it was a struggle to look after his care. My two sisters and I, we all lived hundreds of miles away from him. And I think something that I think a lot of us in this room have probably experienced, tempers would flare. And the relationship that I had with my sisters would fray. And the typical flare-up would be we would get a golden 15-minute call with one of the specialists, Dr. K, and we would argue about how to use that time. And so what was incredibly empowering for me, just speaking as a consumer of healthcare, trying to navigate a very complicated healthcare system in the care for an elderly loved one, was to be able to give all of our notes, all of the lab test results, explain the situation and say we're going to have this call. What are the two things we should talk about? And it, hallucinated or not, I think it gave us great advice consistently. It just brought the temperature down and allowed us better tools to operate as a family here. And that's a story that we hear over and over and over again out in the world. But the future implications, God, I don't know.
You know what? Let's, because now we have 9 minutes. I really want to get a few questions. So let's make some short questions and short answers. Go ahead, Sarah.
Short question. No one's touched on regulations and where it's going to come from.
So regulations, where is it going to come from? Shinjini?
Sure. So I do think that regulation kind of lags behind the technology development. So those are open questions. And it's known that our current frameworks that, for example, the FDA has for approving medical devices don't 100% fit with devices that are continuously adapting and continuously updating. And so I know that the FDA is trying to figure that out right now. And it is something that we would, we're looking forward and anticipating. But that's a great question. Regulation is definitely one piece. Another piece I'll add to that is standards, because those are also missing. We right now are relying on the companies or the developers' word for it, that this is like 100% accurate, right? But we don't have like an external certifying body or an external test to be able to tell us that, okay, all of these models have been run through the same test and this is how they compare. So that's another area that's missing. And I do think that's one place where we would need to, kind of see how, different regulatory bodies react.
There's a paper 2 days ago in Nature criticizing the EU AI Act because the EU AI Act was suggesting lower regulatory barriers for open source large language models, but without defining what the heck open source means. So I think there's just a lot of tooling that regulators still don't have.
My mother, may she rest in peace, would hate that I'm pointing. She said, don't point at people. But that woman right there behind you, yeah, thanks.
Thank you very much. I'm fascinated about how AI will detect Alzheimer's and Parkinson's disease and all these diseases, because everybody I know, I hear every day, this one has Parkinson's, this one has Alzheimer's, dementia. When is this going to happen, and how is it going to help?
I think that there's been a lot of exciting developments in Alzheimer's treatment in the last couple of years. So prior to, let's say, 2020, there was no way to slow the progression of Alzheimer's. It was really just symptom management and trying to do, different things to support the patient as they get worse gradually. And then we had the first drug that was approved by the FDA to slow Alzheimer's, which was very controversial, Aduhelm, if anybody remembers that news. Sure. And then after that, we had the second drug, lecanemab, and we just had the third one, donanemab, which was just approved earlier this month. So as you can see, we've had no drugs to slow progression, and then in the last few years, we've had 3. And so I really hope that the space is heating up. I hope to see many more drugs. I hope to see drugs for Parkinson's, and then drugs to slow disease coupled with early detection, I think could make all the difference for all of those patients who are going to be diagnosed.
Because these effects were in people who, and it slowed the degradation, it didn't reverse it, but they were in people with mild cognitive impairment. So the earlier you can find it, and the thinking has been, we've been treating people too late. It's like somebody's had 5 heart attacks, they're in failure, and then you say, here's some Lipitor. It's like too late. You want to get them early. Where are we? Who's that is a different seminar. No, seriously, I don't mean to give you the problem right now is, and there are plenty of companies out there who will test you, is what's the benefit of doing a test at what stage, and what information do you get from it, and can you do something with that information? You see these with the whole body MRIs that people are doing, and what do you do with it? You find an 8-millimeter nodule in the pancreas of a 38-year-old woman. What do you do with that aside from scaring the heck out of her? So this is, I didn't mean to be, tongue-in-cheek with the answer, but it really is a huge discussion, and it should be another seminar about like, who should get the tests? When should they get them? There's a lot more now. You're going to be having more and more ability to test and find things early genetically. Not even having to do spinal fluid tests. So it's a great question, but we don't have the answer here. We have 4 minutes and 47 seconds. Yes, sir. Loud.
I grew up with television. The current generation is growing up with iPhones and on the internet. So the generation that's growing from generative AI, maybe Gen, how do you think they are going to be affected by this new technology?
You should take that.
Go for it, Jodi.
That's my biggest concern. So I think, again, lots and lots of benefits. Like, we need AI. There's so many things we were talking about, even to help avoid conflicts. And, for climate change, there's so many predictive capacities that will come, as Peter said, out of AI that can help the next generation have a planet. So all of that. I'm just looking at the social communication part. And basically, my concern is that with just immediate next generation, with 60% of them having extreme loneliness and being online all the time, then becoming socially anxious, which is a high, like off the charts social anxiety, they'll be able to have really sophisticated language models to talk to instead of people. And my concern, first of all, it's one way because the ChatGPT empathizes with you, but basically you can have a generative AI that validates your view. Think about that. We're already having a lot of problems in this country because people only talk to people that validate their point of view. They don't want to talk across differences. That's why empathic curiosity is my model, which is learning something new. Like Jon said, what is he missing about other people? I think it's going to become a self-validating tool. People are going to become more isolated. They're going to lose that muscle that, if your machine's giving you empathy all the time, you don't have to give it back to the machine, right? So my worst nightmare is it'll become like our GPS, where we have no sense of direction anymore. None of us can do that. I'm worried that we're going to lose our skills to listen to other people, because we'll all have our machine listen to us, and nobody will have to really have those bilateral, empathically curious conversations. So that's why the last plug I'll give about regulation is the regulation that we've been pushing for is of the model that made that guy that I told you the story about Get Addicted, which is all the unregulated. This is not the healthcare companies and the FDA, but all the unregulated ChatGPT type relationship companies. They all basically use, like social media does in general, an irregular reward system, which is the same as slot machines in Las Vegas that give you dopamine bursts. And I think, especially for youth, that all these technologies should be regulated to be not allowed to use irregular rewards, so that we don't all become completely addicted beyond what we've seen now.
And I think we can get faked out by technology, right? We trust it. We've talked about hallucination.
We put Eliza in the early 1960s was the first computer thing that just literally repeated your words, and people felt loved. I mean, we're projecting machines. We will be perfectly happy talking to bots and not people and being less anxious, but then we won't be able to talk to each other.
And we can assume that the technology is going to bail us out, but we may not know when it's faking us out and when it's not coming through for us. And that moment when if you're looking at a scan and it says early Alzheimer's and it's hallucinating, and I know you're working on ways of getting it not to hallucinate, and it can't quite explain to you how it arrived at its conclusion, that's really disconcerting. And we know that this is amazing technology, and yet there are lots of things we can't do. We can't lower the lights over there so that we're not doing like this, And I don't mean that as a jab at the lighting people, but that's, sometimes things happen, and you roll with the punches. And so rolling with the punches in medicine, I think at the end of the day, I mean, my closing thought would be, we're humans, and my father-in-law used to say, it's hard being a human. It's hard being a human. And maybe part of, when it's so interesting, that point about bias, that makes you human. And the thought that, AI is going to become us or replace us, I'm actually not afraid personally of that, because I think that if we're thoughtful about it and we do use it as a tool, it could be incredible. But we have to keep our guard up. We really do have to keep our guard up. And with that, I thank you all for listening, and thank the three of our amazing panelists.